Imagine a world where machines can recognize faces, translate languages, diagnose diseases, and even compose music. This world is not science fiction. It is happening now. Artificial intelligence, or AI, is reshaping how we live, work, and think. From voice assistants in our homes to algorithms guiding self-driving cars, AI is becoming the defining technology of the 21st century. But what is artificial intelligence? How do machines learn? And can they truly think the way humans do? This documentary will explore the science of AI, from its origins to its breakthroughs, from its promises to its challenges. We will reveal how machines are learning to think, and what this means for the future of humanity. The dream of creating intelligent machines is ancient. Stories of mechanical beings appear in Greek myths and medieval legends. But the modern story began in the mid-20th century. In 1956, a group of scientists gathered at Dartmouth College in the United States. They believed that intelligence could be described so precisely that it could be simulated by machines. This event is often called the birth of artificial intelligence as a field. Early efforts focused on symbolic AI. Researchers programmed rules and logic into computers. These systems could solve puzzles and play games like chess, but they struggled with complexity and unpredictability. The field advanced slowly, with periods of optimism and disappointment known as AI winters. Yet the idea of machines that learn never disappeared. It waited for data, algorithms, and computing power to catch up. At the heart of modern AI is machine learning. Unlike traditional programming, where humans write explicit instructions, machine learning allows computers to learn patterns from data. One key method is supervised learning. Here, algorithms are trained with labeled examples, like thousands of pictures of cats and dogs. Over time, the system learns to distinguish them. Another is unsupervised learning, where machines find patterns without labels, clustering similar data together. Reinforcement learning goes further, training systems through trial and error, much like animals learning by rewards and punishments. The most powerful breakthrough came with deep learning. Inspired by the human brain, deep neural networks process information through layers of artificial neurons. These networks can recognize speech, translate languages, and generate realistic images. Machine learning is the foundation of today's AI revolution. It is how machines are learning to think. Artificial intelligence is no longer hidden in laboratories. It is embedded in daily life. Search engines use AI to rank results. Streaming services recommend music and movies. Online retailers suggest products based on browsing history. In healthcare, AI analyzes medical images to detect cancer earlier than human doctors. In finance, it monitors transactions for fraud. In transportation, AI guides navigation systems and autonomous vehicles. Even agriculture benefits, with AI-driven drones analyzing crops to improve yields. Education platforms use adaptive learning to personalize lessons for each student. AI is becoming invisible infrastructure, shaping decisions, predictions, and experiences. For many people, it already acts like a silent partner in everyday choices. The question remains, are machines truly intelligent? AI systems excel at narrow tasks. A chess program can defeat grandmasters. A translation app can process dozens of languages. But these abilities are specialized. They lack the general intelligence of humans, who can adapt to new situations with creativity and common sense. Researchers distinguish between narrow AI and general AI. Narrow AI solves specific problems. General AI would understand and learn any intellectual task a human can. General AI remains theoretical. Machines do not yet possess consciousness, emotions, or self-awareness. They process patterns but do not understand meaning in the human sense. Still, advances are closing the gap. Language models can generate human-like text. Robots can learn to manipulate objects. The line between simulation and true intelligence grows more blurred with every breakthrough. To understand how machines mimic thinking, we must look closer at neural networks. Artificial neurons are simple mathematical functions. When arranged in layers, they can detect increasingly complex features. In image recognition, early layers detect edges, middle layers recognize shapes, and deeper layers identify faces. Training these networks requires vast data sets and immense computing power. During training, algorithms adjust the weights of connections, gradually improving accuracy. This process is similar in principle to how human brains strengthen or weaken synapses through experience. But neural networks are not exact replicas. They are mathematical models inspired by biology. Despite their differences, the success of deep learning shows how powerful pattern recognition can be when scaled to billions of calculations. Artificial intelligence holds immense promise for the future. In medicine, AI may design drugs, predict epidemics, and personalize treatments. In climate science, it can model weather patterns and optimize renewable energy. In space exploration, AI navigates rovers on Mars and processes data from telescopes scanning distant galaxies. AI could also transform work. Automation may handle repetitive tasks, freeing humans for creativity, empathy, and innovation. Education may become more personalized, finance more secure, and agriculture more sustainable. The potential of AI to solve global challenges makes it one of the most powerful tools ever created. If guided wisely, it could improve billions of lives. With power comes responsibility. AI also raises risks and ethical dilemmas. Bias in algorithms can reflect or amplify human prejudice. A hiring system may unfairly reject candidates. A facial recognition tool may misidentify certain groups. Privacy is another concern. AI thrives on data, but collecting and analyzing personal information raises questions about consent and security. Automation threatens jobs, especially in industries with repetitive tasks. Societies must adapt with new skills and social protections. Finally, the pursuit of general AI sparks debates about control. Could highly advanced systems act in ways we cannot predict? Researchers stress the importance of safety, transparency, and accountability. The future of AI depends not only on science, but on ethics and governance. So where is AI heading? Most experts believe we are entering an age of hybrid intelligence, where humans and machines work together. AI will amplify human capabilities rather than replace them entirely. Advances in neuroscience may also inspire new forms of AI, while brain-computer interfaces could connect biological and digital systems. This convergence blurs the boundary between human intelligence and artificial intelligence. The future will not be machines alone, nor humans alone, but collaboration. The key is ensuring that AI serves humanity's values, creativity, and well-being. From myths of artificial beings to today's algorithms, the dream of intelligent machines has traveled a long road. Artificial intelligence is no longer a fantasy. It is a reality shaping medicine, science, technology, and daily life. Machines are learning to think, but their intelligence is different from ours. They process patterns, while we seek meaning. The search for true machine intelligence continues. It raises profound questions about what it means to be human, how we define consciousness, and how we choose to use the tools we create. AI may not replace humanity. It may instead reflect the best and worst of us. The choice is ours. This is the story of artificial intelligence. This is the hidden universe revealed. If you enjoyed this journey, subscribe for more explorations into science, discovery, and the future of technology. Long before modern algorithms, humanity experimented with mechanical logic. In the 17th century, philosopher Gottfried Wilhelm Leibniz imagined a universal machine that could compute any logical statement. In the 19th century, Charles Babbage designed his analytical engine, while Ada Lovelace speculated it could one day create music. In the 20th century, Alan Turing proposed the idea of a machine that could simulate any mathematical process. His concept of the Turing machine laid the foundation for digital computing. Turing also asked a deeper question: could a machine ever think? His famous Turing test suggested that if a machine could carry on a conversation indistinguishable from a human, it could be called intelligent. This historical context shows that AI is not just a product of the 21st century. It is a centuries-long dream of combining logic, mathematics, and imagination. The 21st century brought an explosion of data. Every smartphone photo, social media post, credit card transaction, and GPS signal produces digital traces. In fact, more than 90% of the world's data has been created in just the last 2 decades. This ocean of data became the fuel for modern AI. Algorithms learn by finding patterns, and the more examples they process, the better they become. Without massive data sets, deep learning could not have achieved breakthroughs in speech recognition or image classification. Cloud computing provided the necessary infrastructure. Instead of a single computer, Thousands of processors now work in parallel to train models with billions of parameters. This combination of big data and computing power transformed AI from theory into everyday reality. To understand the reach of AI, consider 3 examples. In healthcare, a system developed at Stanford University detected skin cancer from images with accuracy comparable to expert dermatologists. In some hospitals, AI now supports radiologists by flagging suspicious X-rays. In transportation, Waymo's self-driving cars in Phoenix, Arizona, navigate city streets with sensors and AI, transporting passengers without a human driver. In disaster response, AI-powered drones survey damage after earthquakes or floods, guiding rescue teams to where help is needed most. These cases show that AI is not abstract theory. It is saving lives, improving safety, and making critical services more efficient. Researchers worldwide pursue the holy grail of artificial general intelligence, or AGI. Unlike narrow AI, AGI would not just master one task. It could learn across domains, reason with abstract concepts, and perhaps even exhibit creativity. There are different schools of thought. Some scientists believe scaling current deep learning models with larger datasets and more powerful computers may eventually lead to AGI. Others argue that a completely new paradigm is required, inspired more deeply by neuroscience. Projects like OpenAI, DeepMind, and major university labs are exploring reinforcement learning, symbolic reasoning combined with neural networks, and hybrid brain-inspired architectures. AGI remains distant, but its pursuit forces humanity to reflect on what intelligence really means. Artificial intelligence will reshape economies. According to studies by consulting firms like McKinsey and PwC, AI could add trillions of US dollars to global GDP in the coming decades. Automation may eliminate some jobs, especially repetitive tasks in manufacturing, data entry, or logistics. But AI may also create new jobs in design, robotics maintenance, data ethics, and creative industries. Countries that invest heavily in AI research may dominate future markets. China, the United States, and the European Union are competing to lead in AI innovation. This technological race will shape global power balances, just as oil and electricity shaped the 20th century. For workers, the challenge will be lifelong learning, acquiring new skills to work alongside machines. Governments and businesses must ensure that the benefits of AI are shared broadly. Artificial intelligence may also help fight climate change. By analyzing satellite images, AI tracks deforestation in the Amazon rainforest in real time. It predicts energy demand to optimize renewable energy grids, balancing solar and wind power with storage systems. AI models climate change scenarios faster than traditional systems, helping policymakers prepare for floods, droughts, and hurricanes. In agriculture, AI reduces pesticide use by identifying pests early, saving both crops and ecosystems. If guided wisely, AI could become a partner in sustainability, protecting the very planet that gave birth to intelligence in the first place. Ethical debates grow as AI advances. Some experts call for algorithmic transparency, meaning companies must explain how AI makes decisions. Others demand stronger privacy laws, limiting how corporations and governments collect and use personal data. Military applications raise further concern. Autonomous weapons could one day act without human intervention, raising moral and legal questions. Philosophers also ask whether highly advanced AI, if it ever develops self-awareness, should be granted rights. Could a machine ever be considered a person under law? While these debates may sound speculative, they highlight how quickly AI challenges traditional definitions of morality and justice. What might the year 2050 look like? Cities may be managed by AI systems that regulate traffic, energy, and emergency services. Personalized digital assistants may plan our daily lives, from health monitoring to financial advice. Brain-computer interfaces could allow humans to think commands directly into devices. But the essence of the future is not about machines replacing people. It is about collaboration. AI will be powerful, but human values, culture, and creativity must remain at the center. The story of AI is also the story of human responsibility. The challenge is to use this technology not only for profit or power, but to uplift humanity and expand the possibilities of knowledge and compassion.